Hello everyone and a very good evening. So how are you all doing? Yes, we have Saif Pasha. Yes, Ruhi is here. Good evening Suresh Tagore. I am doing good. Thanks for asking. Hi Disha Bhatt. Nasreen Ansari. Great. Good. Yes. Good evening Fenil. We have Ehsas Gupta. Yes. Good evening Yasharth Kesarwani. Hi Aditi Datta. Hi Dipti. Yes. Charvi is here. Ayushi Datta, Papiya Das, Mahendra Singh, Rani P, Ardra. All right. So I'm visible and audible to everyone. Yes. Kamla Kumari, hi. Yes. Keshri Bagela says you're audible and visible. Well, I am doing good. How are you all? Yes, absolutely Bhagavardhan. Thank you. Bandana Mishra, Sarvesh Singh Chauhan, live. Yes, Ruchi Verma, Abhishek Kumar, Yash, Amal S. Yes, Agamya Pandey. All right, so there is no glitch at all. We can continue. My name is Khushbu and a very warm welcome to yet another wonderful session. So you all know what today's session is about. Yes? You would have seen the title of the video by now. So today we are going to have a session on some applications of trigonometry. It's basically a one short session. So I'll be covering all the concepts that we have in this chapter along with a few questions as well so that you get a better understanding. Yes, Ehsas Gupta says. Aditi Datta. Yes, Mahendra Singh. I'm excited too. All right. So before we start off with the session, before we go into the details of this, let's do a quick recall of what we have learned in the chapter trigonometry that you have studied in term 1. So we'll start recalling the concepts from this chapter. So let's first recall the trigonometric ratios, right? So you all can see it's a right angle triangle. Yes. So here this is the 90-degree angle Q. This is the angle theta and this is the side QR which is opposite to it. This is the side PQ that's adjacent to it and this is the hypotenuse. So we all know about the trigonometric ratios really well. Yes. Sin theta is opposite side by hypotenuse, right? And cos theta is adjacent side by hypotenuse and tan theta is opposite side to the adjacent side. Yes, you can remember it this way as well, O by H, or you can say A by H, like this, right? We will be doing the values of trigonometric tables for specific angles as well. Yes, D. Deepak, you love this chapter, easiest chapter in mathematics? Yes, indeed it is. Trigonometry, as I always say, it is one of the easiest and the most interesting chapter of grade 10th, right? Keshri Waghela, easy peasy, lemon squeezy, yeah? Yes, gaming gangster, I do remember you. Yes. All right. So this was about the trigonometric ratios. Yes. Now let's do a quick recall of the trigonometric ratios of standard angles. Yes, Disha Bhatt, ready? Yeah. Okay. No, Papiya Das, we won't have Menti today. We'll be covering, as I said, all the concepts that we have in this chapter in one go. Yes. Okay. So here, first we write down all the angles, that is 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. And here we have the trigonometric ratios, sine, cos, tan, cosec theta, sec theta and cot theta. So maximum times I have seen that students ask me how to remember this table. Is there any trick? Yes, we do have a trick. What you can do is, first you write these degrees in this order, 0, 30, 45, 60 and 90, right? So we will just find out the values for sine theta, right? Just by knowing the values of sine theta for these specific angles, you can find out the value for any of the other trigonometric ratio. So first write down 0, 1, 2, 3 and 4 like this, right? And then you take then we divide them by 2, all of these by 2, right? We divide all of these by 4. We divide all of them by 4 Once you divide by 4, you take the square root of each one of them. So 0 by 4, that's 0 only. Square root will also be 0. 1 by 4, that's going to be what? That would be 1 by 2. 2 by 4, that would be 1 by root 2. And this is root 3 by 2 and this is 1. That's how you can remember the values for sine theta at these specific angles. Do not change the order. When it comes to cos theta, if you know these values, all you have to do is reverse this order. Like sine 90 is 1, so cos 0 would be 1. We are reversing it, right? Tan theta is nothing but we know that tan theta is actually sine theta by cos theta. Let's suppose I need the value of tan 30. So simply I'll write sine 30 degree by cos 30 degree. Put the value of sine 30 and cos 30, divide them, you get this value. See, in case you're not able to memorize this table, you're not able to remember this table, you can use this trick, right? In the exam, let's suppose you forget any value, you can use this trick to know the value of that particular trigonometric ratio. Yes. Agamya Pandey, the other chapters, yes, we will be covering all the chapters that you have in term 2. And we have done sessions on the other chapters as well before. Yes. Yasharth Kesarwani, I remember that I had given you the homework in the previous class and I saw that few of the students have responded to it, but not all of you. That's what I told you. How would I know that you all have actually done it? So I wanted answers from each one of you in the comment section. After the class, today also I'll give you the homework after this class. So once the class gets over, you can try out the questions and give your answers in the comment section so that I would know that actually all my students have done it. Yes? Papiya Das, great trick, really impressed. Thank you. Yes. Very good, Sayani. Very nice. Yes, Charvi, I remember that you responded. I remember, even in fact, I remember a few names. I remember the names of the students who have responded to it. But not all of you have done it. Yes, Fennel, you remember this table fully? You also use this trick, yeah? Yes. Alright, okay. That's okay, Disha. Today also I'm giving you the homework so you can try out the questions and respond in the comment section. Alright, okay. Okay, now similar way, cosec theta is reciprocal of sine theta. Let's suppose I need the value of cosec 60. What I'll do is I'll take reciprocal of sine 60. That would be 2 by root 3 then. Sec theta is reciprocal of cos theta. To take reciprocal of cos value at that particular angle. Similarly, cot theta is reciprocal of tan theta. So that's how you can memorize this table, right? Now let's try out a question based on these two concepts that we have covered till now. So here we go. Yes, Fennel, I remember you were the first one to respond. Yes. Yes, alright. In the given figure, the value CE is dash, right? You can see the figure over here. Here we can see that AD is 6 centimeter, AB is 10 centimeter, and angle ECB is 60 degree. So what the value of CE is? Just by these two concepts that we have just learned, we can use them to get this value. So this is what? We can see that it is in this right angle triangle ABC, right? I'm sorry. This is a right angle triangle and here we can see that all these corner angles over here, these are 90 degrees, right? Angle A, B, C and D all are 90 degree. AD is 6 centimeter and AB is 10 centimeter. Since all angles are 90 degree, I can call this a rectangle since you can see these two adjacent sides are of different length. Since it's a rectangle, so this BC will be also of 6 centimeter as opposite sides of a rectangle are equal, right? So this, in this right angle triangle, this one, CBE, I can say that cos 60 degree is BC by CE, right? That's going to be 1 by 2, which is equal to 6 centimeter by CE. Put this value here and you get 12 centimeter. Absolutely. Vedant, Nandanwar, yes. Ishtiyaq Khan, 12 centimeter is the answer. Yes. Sanskruti, Shreyans, yes. Basudev Das, Naveen Kumar, Aditi Datta, Nikesh Madhavi. So you all know how to solve this, right? A very simple question. Now, so before, since this session is about the applications of trigonometry, so we should be able to relate it to real life in some way or the other, right? So let's consider a situation over here. So here we can see a girl is standing and let's name her Pia, right? And you can see that she's looking at a bird which is sitting in a hole inside the bark of the tree, right? So this bird is exactly in front of her eye and you can see that there is a line which is connecting Pia's eye to this bird. So this dashed line over here that we are showing, this is known as the line of sight. So you need to remember this term because this will surely come up in future. Yes. For trigonometric ratios, to remember that, this is P, B, P, H, H, B, right? So here we have sine, here you write cos, here you write tan. So there are few mnemonics that we can use to remember that, like Pandit Badri Prasad har bole, right? And this is Sona Chandi Tole, like something like that mnemonics you can use to remember them. And we know that sine and cosec are reciprocal of each other, cos and sec are reciprocal, tan and cot are reciprocal, right? Yes. Yes, Mahendra Singh, that's the line of sight. You can see that it is connecting the observer's eye to this object that she is viewing. It is right in front of her. Yes, Yasharth, I do remember. Yes, I actually checked that after the session. All right, all right. For tomorrow's session, I'll tell you right after the class. Once this class, before this class gets over, I'll tell you. Yes, it is parallel, right? All right, all right. Now here you can see that Pia is looking that the object here, this bird which she is looking at, it's basically an object over here, right? So it is said to be the horizontal. It is said to be the horizontal axis. So we can say that if the object to be viewed is straight ahead, then that line of sight is same as the horizontal axis. So line of sight and horizontal axis is one and the same thing, we can say. Yes. All right. Now, when it comes to some applications of trigonometry, there are few terms that we need to know. Now, let's suppose that if Pia were to look at the fruits which are above the bird, right? So here the object that she is looking at, it's basically these fruits, right? Which is high above. So she has to look up to view that object. So you can see that the angle is formed between the line of sight and the horizontal axis. This is the line of sight, right? LOS, line of sight. This is the horizontal axis, and the angle which is formed here, that's theta. It's nothing but that's the angle of elevation. So when the observer is looking up to view an object, angle of elevation is formed at the observer's eye. Yes, Fennel, you like this trick? Yeah, we used to use this trick when we were in school actually. Yes. That's angle of elevation, not deviation. Yes, Agamya Pandey. Abhishek, ma'am, doubt if not given this value, can we solve if question give to find out? Sorry, I could not understand, Abhishek, what you're asking. All right. Now we'll talk about the angle of depression. So look at these beautiful flowers which are at the bottom of the tree, right? You can see that Pia is looking down to look at these flowers over here, right? So the object over here are nothing but these flowers over here, right? So when she has to look down to view an object, so you can see that angle is formed between the line of sight and the horizontal axis, which is theta here. It is nothing but that's the angle of depression. So when the observer is looking down to view an object, an angle of depression is formed at the observer's eye. It is between the horizontal axis and the line of sight. Yes, must trick, yeah. At least you will be able to remember it, right? Yes, Charvi, absolutely. When you're looking down, that's the angle of depression, not deviation. Yeah. Okay. Vedant, yes, we have a class tomorrow as well. All right. So Pia is curious, just like you guys are getting. She wants to know the complete details about this chapter. So this time what she is doing is, to understand this better, she is considering here, she takes an example of Qutub Minar. I'm sure that all of you must have heard about it or even visited it, right? So there are some assumptions that are made while solving questions based on angle of elevation and angle of depression. So here you can see that the observer is here. That's an extended object, right? So she is standing over here. So we always consider the observer as a point object, right? We consider the observer's eye, right? So we consider that as a point object, and this 3D object will be considered as a line, as a straight line over here. Now you can see right here the angle is formed between this horizontal axis, right, and the line connecting the observer's eye to the top of the Qutub Minar, which is 45 degrees over here. Yes. No, there won't be Menti today. We won't have Menti. This is the distance. You can see the base level between the observer's eye and the base of the Qutub Minar. That's 73 meter. But this is the angle of elevation. Observer is looking up to view the top of the Qutub Minar. That's 45 degrees. Yes. All right. Now, one more thing that you need to keep in your mind, that we never consider the angle of elevation or depression from the vertical axis. Like you can see over here, this line is parallel to the straight line, right? This angle over here is also 45 degrees. Though the measure of the angle is same, but we never consider it from the vertical axis. We will always measure it from the horizontal axis. This angle would be 45 degrees when we are talking about this angle of elevation, right? Even angle of depression also, it is considered from the horizontal axis, not the vertical one. Yes. Anshuman and Mohammed Shamil, you want me to explain this one more time? See, when we are considering the angle of elevation or depression, we are considering the horizontal axis, right? So this is the observer eye, this is the top of the Qutub Minar. Observer is looking up to view of the object, so angle would be formed here. From vertical axis, we will not consider it, right? Even when you're talking about the angle of depression, so observer would be up somewhere and it would be looking down to view something. In that case also, the horizontal axis would be considered. Yes, that is Keshvi. PBPHHB, you can write sine, cos, tan over here. Pandit Badri Prasad, har har bole, sona chandi tole. There are so many mnemonics that you can use to remember it. You can make your own mnemonics as well. Suresh Tagore, Byjus is a great application and you are a great master teacher. Thank you. Yes. All right. So before we go forward, there are some things that you need to remember. So particularly understanding how to draw diagrams, because this is one thing that we actually need when we are solving questions related to this chapter. So you can see here that this is the observer's eye, right? We always consider it as a point object, and this is the 3D object Qutub Minar, and we will visualize this as a straight line over here, right? So you can see that here the angle is formed between the observer's eye and the top of the Qutub Minar. The line is connecting it, and the angle is formed between the horizontal axis and this line. This is the line of sight. That is 45 degree. Yes. All right. We do not have to find out the height and the hypotenuse here. No need. Vedant's session is super amazing, ma'am. Thank you. Yes. All right. Sure, Sayani, when it comes to questions, I'll tell you how to solve them easily. Don't worry. Yasharth Kesavani, test paper series. Yes, surely we will come up with that as well. Don't worry. Suresh, understood? Yes. All right. Now, important thing that you need to know here is whenever certain data is given, it is important to understand that we generally do not consider their 3D forms. Here, Qutub Minar is a 3D object. So, we are not considering it as a 3D form. We will consider them as points and lines. This will be considered as a line, straight line. And here, observer would be considered as a point object, right? So, this is a very important thing that you need to know when it comes to drawing the diagrams. Yes, Yasharth, crystal clear? Let's move ahead. Alright, now let me give you some tips while handling the problems related to real life situations. Like I mentioned before, if you have a building or a tower, we will consider it as a line and the observer is considered at the point object. I'm repeating it one more time, on the horizontal ground until we are asked to use its height. Until unless it is mentioned in the question, we are not considering the observer's height. Yes? Sayani, Byjus is a... Sorry, I could not read the entire comment. Ma'am, exam में कुतुब मीनार नहीं निकालना है. See, Deepak, if it is asked in the question, first of all, it's a 3D object, right? When it comes to questions, I'll just show you, right, how we solve questions, because we will be using straight lines and points only, right, in the figure. So if it is asked in the exam, then definitely we have to find out the height. All right. Okay, so let's move ahead. Now, what about the times when the horizontal line is no longer on the ground? Like in this case, you can see over here. Here we have this. Suppose we are actually considering the height of the observer and the platform in which it is standing, right? Before that, I told you that we consider observers at the point object if it is not mentioned in the question to consider its height. But this time, let's suppose we have a case when we have to consider the observer's height as well as the platform in which it is standing. So So both the cases I'm showing you in this figure only, right? So here you can see observer is looking up at the top of this building, right? So in that case, what we do is, since the observer is looking up, you can see that This is the horizontal axis now. This is the line of sight. This is the horizontal axis, HA, that's for horizontal axis. So you can see this angle is formed over here. This is nothing but that's the angle of depression because, that's the angle of elevation because observer is looking up to view an object, right? Thank you, Rudra Pratap Singh. Thank you. Yes, so, and here if you see, observer is looking down at the bottom of the building, right? So here when observer is looking down, so angle of depression would be formed. So here this is the horizontal axis, right? So that's the theta. All right. So when it's so if we need to consider the height of the observer of the height of the platform, we say that horizontal reference changes and is no longer on the ground. So both the cases I have shown you in one diagram only. But let's suppose if we are considering only one case, right? So this is the horizontal axis in that case, but here both the cases when we are considering in one diagram, so this is your horizontal axis over here, right? Prem Jakar, thank you for such kind words. We will be solving a few questions, don't worry. Pratima Mishra, great explanation on Byjus only by great teachers. Thank you. I hope this is clear to everyone. Yes? Agamya Pandey will be solving a few questions. Do not worry. Yes. Crystal clear? Disha Bhatt? Yes? Alright. Alright. Let's move ahead. Let's solve a few questions so that you get a better understanding and whatever doubts you have in your mind, they will also be clear. I can see a lots of thumbs up. Yes. Suresh, Surajpal, Rishabh Gupta, simple one, right? Charvi Parker, clearly understood ma'am, love your teaching. Alright, cool. So here we have a question, let's try this together. So if a tower 30 meters high cast a shadow 10√3 meters long on the ground, then what is the angle of elevation of the sun? Let's make a figure. This is our tower, let's suppose we are considering the Eiffel Tower, 30 meter high, right? Sun is here. So sun is overhead, right? So here it is casting a shadow of 10√3 on the ground. This is the shadow, right? So what is the angle of elevation of the sun, right? Here this theta is representing the angle of elevation, right? So in the exam you would not be drawing the sun, you would not be drawing the Eiffel Tower, you will just be drawing a right angle triangle, okay? Now this is just for your understanding, we have shown you this way. Yes, Krishna Shashank. One more time. Yep. Tower is 30 meter high. This is the tower. This is the tower's height. We will consider it as a straight line. And it is casting a shadow of 10√3 on the ground. Here this is the shadow, this is the tower, right? What is the angle of elevation of the sun? This is the angle of elevation. Let's denote this by theta. We need to find its value. Fahim Mustafa, although there is no need to use the Pythagoras theorem, you can use that, it is not wrong, but that would be much more time consuming in that case. See, directly you can use a trigonometric ratios to find it out. In this right angle triangle ABC, what do I need is I need theta. I am giving these two values are given. We know that the side opposite to the angle, to the considered angle, to this theta, this is nothing but that's the opposite side and this is nothing but that's the adjacent side, right? So this is opposite side to the adjacent side and that's going to be what? This is tan theta. That's AB by BC. So what is AB? That's 30. BC is 10√3. This gets cancelled out. We have 3 by √3. This gets cancelled. We are left with √3. So think about the trigonometric ratios for specific angles. Tan 60 is √3. So that means theta in this case is going to be 60 degrees. That's the angle of elevation. Right? Ishtiaq Khan, yes, 60 degree. Correct, Bhagyavardhan. Disha Bhatt. Kashish, right. Meena Majumdar, yes. Raj Nandani, Agamya Pandey. That's okay, Papiya Das. Whatever you missed, you can watch that later on because you would have the recorded session on the YouTube, right? Aditi, correct. Himadri T, yes. Diksha, Agamya Pandey, Epic Gaming, Srijita Moitra, Vartika Kansal, Abhinay, tan 60. Rohit, you want me to explain again? So what we are doing here is, this is the tower's height, right? We will represent that with a straight line. This is the shadow. Obviously, shadow will be formed on the ground and we connect this with the top. So we get the angle of elevation here. That's theta. So we are given these two values. Think about the trigonometric ratio, right? Which has opposite side and adjacent side. Only cot and tan. So you can either use cot or tan. So I'm using tan here to get the value of theta. Yes. Utkarsh, that's okay. We still have time, right? So we'll be doing these sessions on each and every chapter that you have in term 2. Don't worry about it. Epic Gaming, ma'am, I like your teaching method. Thank you. Yes. J, values in decimals. See, even if they are in decimals, at the end you would get such value so that, you know, they would have some value of the specific angle. Or if it doesn't come under 0 degree, 30 degree, 60, 45 or 90, so in the exam they will mention here. They will mention the degree along with that value. Don't worry about it. In 10th grade, they do not give you such values. Triangle ABC, you are saying you can use Pythagoras theorem to find it out. See, first you will use Pythagoras theorem. You would find out it's going to be a little time consuming. I tell you why. You will use Pythagoras theorem. Then you will find out the hypotenuse. Then again, you would have to apply some trigonometric ratio to get this value of theta, right? So why do we have to do one more extra step? Vedant understood very well. All right. Anshuman Ranjan, Miss Byjus is the best learning session. Thank you. Okay. Yes. Rajkumar K, ma'am, you are the best. Thank you. Yes. So I hope this is clear to everyone. Yes. Okay. All right. Let's try out one more question. So this is let's increase the level of the question a little bit. So angle of depression from the top of Eiffel Tower to the foot of a building is 60 degree, and angle of depression from the top of the building to the foot of the Eiffel Tower is 30 degree. If the height of the building is 50 meter, find the height of Eiffel Tower. See, when it comes to applications of trigonometry, all we need is read the question carefully, draw the figure, right? Once you have drawn the right figure, understand that your half of the question is done. Trust me. Yes. Okay. So we are talking about Eiffel Tower and we are talking about a building. So here we have the Eiffel Tower and the building. Obviously Eiffel Tower would be bigger than this. The angle of depression from the top of the Eiffel Tower, right, from here to the foot of the building is 60 degree. So to the foot of the building, that means observer is here, observer is looking down here to the foot of the building, right? And we will join their bases. Exactly. And angle of depression from the top of the building to the foot of the Eiffel Tower is 30. We will come to this later on, to this statement. Height of the building is given, that's 50 meter. We have to find out the height of the Eiffel Tower. As I said, we will represent them with straight lines and right. So let's first understand this. We will connect their bases, that's the horizontal axis. This is the Eiffel Tower's height. So from the top of the Eiffel Tower to the foot of this building. What is given? Angle of depression. That's how we represent angle of depression. These lines are parallel, so this will also be 60 degree. I can see answers have already come people have already started giving answers in the comment section. Wow. Yes. Okay, so the height of the building is given, that's 50 meter, and let's label all this. And let's assume that the height of the Eiffel Tower is h meter. So in this right angle triangle ABC, I can use cot or we can use tan also, right? Cot 60 degrees what? That BC by AB. So cot 60 degree would be x by h. I'm just substituting their values. So this would be equals to h cot 60 degree. Let's mark this as equation number 1, right? Coming to the another statement, the angle of depression from the top of the building to the foot of the Eiffel Tower, right? So from the top of the building to the foot of the Eiffel Tower we are looking, right? So from the top of the building we are looking down, so angle of depression would be formed and that is 30 degrees. So this will also be 30, lines are parallel, alternate angles are formed. This is 50. So in this triangle, right angle triangle DBC, I can say cot 30 is BC by DC. You can apply tan as well if you want to. So cot 30 is x by 50. We are just substituting their values. We get x equals to 50 cot 30 degree. That's your second equation. Yes, correct Bhagyavardhan, right. D Deepak, exactly, you can use tan as well because they are only reciprocal of each other, you see, right? Okay. Now we have these two equations and what we can see here is that both of them are equal to x. So we can equate them, right? When two things are equal to the same thing, then they're equal to each other. So on equating them, we have h cot 60 degree, 50 cot 30 degree. So we have h equals to 50 cot 30 degree by cot 60 degree. So h is, we are substituting their values. Cot 60 is 1 by root 3, 30 is root 3. We will cancel them out. We get 50 into 3. That's going to be 150 meters, right? And I think all the students have given the right answer. That's 150 meter. Yes. Thank you, Fresh Mind. Correct, Keshvi Bagela. You can use tan also. This is fine. Yes, we will do statistics also, Mahendra Singh. Don't worry. Each and every chapter that is a part of term 2 will be covered. Yes. Rajkumar K. Clear. Abhinav Srivastav, what we are doing here is, this is the Eiffel Tower. So from the top of the Eiffel Tower, this is the Eiffel Tower's height. Let's assume that as h. From the top here, we are looking down, right? So what is happening here? Angle of depression is formed at 60. So this will also be 60. Lines are parallel, so alternate angle form over here, right? From here, from this top of building, we are looking down at the Eiffel Tower's bottom. So here also angle of depression is formed. That's 30 degrees. So this will also be 30 degree. So one time what you have to do is, you have to apply this the trigonometric ratio thing on this triangle ABC. One time you have to apply on DBC. Tan or cot, whatever you can use. So you will get these values. You can equate them because both of them are equal to x. On equating them, you get this value. You get the value of h. Substitute the values. You get 50 into 3. That's 150 meter. Yes. Dipti, I have repeated one more time. I hope your doubt is clear now. All right, Utkarsh, I'll go a little slow. I'll give you time to solve. Don't worry. Yes. KTB, vlogs and recipe, what if we use tan? Yes, you can use tan also. That's what I'm saying. See, tan is what? That is perpendicular upon base, right? Cot is what? That is base upon perpendicular. They both are reciprocal of each other. In the question, only two things were there, right? We are not using the hypotenuse. So both are correct. Rudra Pratap Singh, very well understood. Yes, D. Deepak, do not worry. Every chapter will be considered, will be covered. Suresh Tagore, crystal clear? Yes. Mahendra Singh, Byjus is best learning platform for students. Teachers are so good, solve each and every student doubt. Think and learn. Thank you. Yes. Sia Midha, clear? Yes. Disha Modi, last one. Both are easy, Kartike. You can use any one. Yes. The last one, you're talking about this step. So h would be 550 cot 30 degree by cot 60 degree. What is cot 30? That's root 3. Cot 60 is 1 by root 3, right? So what we are doing here is, that is 50 times root 3. You are dividing this with 1 by root 3. So this becomes root 3 by 1, right? So root 3 into root 3 would be 3. Yes. So 50 into 3 is 150 meters. Yes. Okay. All right. So I hope that it's clear to everyone. Great. Let's move ahead. Let's take a look at the next question now. So Sam is looking at the roof of the adjacent building from the top of his building. His height is 5 feet. He knows the height of his building and the distance between the two buildings is 20 root 3 meters. 20 root 3 feet, sorry. Sam measures the angle of elevation of his line of sight to the top of the other building to be 30 degree. Based on the given information, find the height of the adjacent building. Okay. So, let's look at the figures first. So, we are talking about two buildings over here. One is Sam's building, one is the building which is adjacent to his building. So, Sam is looking at the roof of the adjacent building. Sam is here. Sam's height is given. That's 5 feet. This time, see, it's an example where we are considering the height of the observer as well, right? Yes. So this is 5 feet, that's the observer's height, and this is the adjacent building, right? This is the adjacent building. This is Sam's building, right? Now, Sam is looking at the roof of the adjacent building. This is the roof of the adjacent building. Sam is looking here from the top of his building. So this is the horizontal axis this time, right? So he is looking up to view this object, I mean the roof of the other building. Then angle of elevation is formed, that's 30 degree. It is mentioned in the question, right? That angle of elevation of his line of sight to the top of the other building is 30 degrees. Now the distance between the two buildings is 20 root 3 feet, that's given. And we're also given that the height of Sam's building is 50 feet. This is also given. This is the given information. We need to find the height of the adjacent building. Now, if you remember, I told you in the beginning that these are 3D objects. So, we will consider them as straight lines, right? So, this is Sam's height, 5 feet, right? This is Sam's building height, that's 50 feet. This is the height of the other building, the adjacent one. The difference between the distance between the two buildings is 20 root 3 feet. So this over here is 50 feet. So this CD will also be 50 feet. Lines are equal and parallel, right? This is 5 feet, that's Sam's height. So this BC will also be 5 feet. I do not know AB. I'll have to find out AB to get the complete height of the building. That's AD. The height of the adjacent building would be AB plus BC plus CD. I hope this much part is clear to everyone. I can see a lot of answers in the comment section. Yes? Okay. So we can move ahead, right? Now we know one thing, that this is Sam's height 5 feet, CD is the height of the Sam's building, that's 50 feet. From this triangle ABO, in this triangle we are considering, tan 30 would be what? That's AB, right, by OB. So I can say that AB would be OB times tan 30 degree because I need AB, that's why I'm finding out its value. OB is what? OB is parallel and equal to this, that's 20 root 3, and tan 30 is what? That's 1 by root 3. Root 3 gets cancelled. What is AB? That's 20 feet. So we have AB, we have BC, and this is 50. I'll simply add all them up to get this value. That's 20 plus 5 plus 50, and that's going to be 75 feet. That's the final result. Yes, Diti? Absolutely. Kartike, correct, 75 feet. Hi, Hoshika, yes. Yashad, 75 feet. Rajnandani, Shruti, Vartika, Disha Bhatt, Mahendra Singh. Bhagyavardhan, yes, correct. Ishtiaq Khan, Hitesh Kumar, yes. Hoshika B, Vedant, Disha Bhatt. So I think all of you have understood how to find this out. So you know that whenever 3D objects are given, we do not consider their 3D forms. We consider them as straight lines. So observer is considered as a point object until and unless mentioned in the question, right? We do not consider their heights if it is not mentioned in the question. Yes, Evergreen Channel BM, Rajkumar K. Rudra Pratap Singh, D. Deepak, Subidha, right, Sia, Nikesh, Madhvi, yes. Yes, Rishabh Gupta. The main challenge over here is to draw the diagrams. Once that is done, trust me, half of the question is done. Yes. Diksha, Byjus make the learning easy. Thank you. Okay, so this was the last question of today's session. Now it's time for your homework. Yes. So we have two questions over here. So first is, a circle artist is climbing a 30 meters long rope which is tightly stressed and tied from the top of a vertical pole to the ground. Find the height of the pole. The angle made by the rope with the ground level is 30 degrees. This is the first question. If you want to note it down, you can note it down in your notebook, or you can take a screenshot also if you want to. So you can try these questions later on after the session and give your answers in the comment section then. Yes. And second question is, find angle of elevation of the sun if a 15-meter high building casts a 15-meter long shadow. Yes, yes. Navin Kumar. Question mein Sam hai kahan? Sorry, I could not understand your question. See, Krishna, this homework is for your practice, right? Instead, I would say that you should practice more questions after the session. I'm just giving you two questions. Yes. Some people have already started giving answers. Good speed. D. Deepak, you took screenshot? Great. You can take a screenshot of it and solve it later on after the class. Yes. Vandana Mishra, Sareem, Hitesh Kumar, Nikhil Thorat, yes. Kartike. I hope that all of you have noted down the question, yes? Mohammed Shamil PS, thank you. Manjeet Kaur. Suresh Tagore, noted, yes. So shall we move ahead? Yes. Thank you, Mahendra Singh. Sorry, Diksha. Yes. Took the screenshot, Rakshi. Yes. All doubts clear? Great, Diksha. Rajkumar S. Yes. For the next session. Agamya Pandey, done. Great. Alright, so there is a lot to cover. We know that there is a lot of syllabus of grade 10th. You all have been asking, when are we going to do constructions? When are we going to cover the other chapters? So please don't worry about it, because this is not the end. We have lined up many more sessions from you for every Monday to Friday to make you exam ready. So we'll be covering everything, whatever we have in term 2. All right, now let me give you a glimpse of the upcoming session. So our next session is on February 1st. That is Tuesday. That means tomorrow at 6 p.m. So tomorrow we'll be covering some critical questions on some applications of trigonometry. Trust me, these questions again are going to be very important from exam point of view. Yes. Thank you, Suresh Tagore. Krishna Sishank, I just told you, tomorrow we are going to have the next session on some, so we'll be covering some critical questions on some applications of trigonometry, 6 p.m. tomorrow. Yes. All right. And you all know that we have 3 trial classes as well, and the link for that is given in the description below. So you can get all your doubts clarified instantly during the class. And please like, share and subscribe so you get notified about the upcoming sessions. So I'll see you soon. Until then, be curious, keep learning. Thank you.